Hello friends, let us solve another problem on quantization. Consider an audio signal with spectral components limited to the frequency band of 300 to 3300 Hz. A PCM signal is generated with a sampling rate of 8000 samples per second. The required output signal to quantization noise ratio SQNR is 30 dB. So first part of the problem is, what is the minimum number of uniform quantization levels needed and what is the minimum number of bits per sample needed? Let us try to solve it. So we are considering uniform quantization first. Uniform quantization, first part of the problem. For a full scale sinusoidal signal, SQNR in dB is given as 1.76 plus 6R, where R is the number of bits used to represent a sample. Given in the problem is that this SQNR must be greater than or equal to 30 dB, and it works out to be R greater than or equal to 4.7 approximately, but R must be an integer, and therefore R is the ceiling of 4.7, that is equal to 5 bits per sample, and therefore the number of quantization levels L, which is equal to 2 to the power R or 2 to the power 5, equal to 32. So to ensure that the output SQNR for the given signal with maximum frequency 3300 Hz to exceed 30 dB, the minimum number of bits per sample required is 5, and accordingly the number of uniform quantization levels required are 32. Now part 2 of the problem asks the minimum system bandwidth required. Now before we do that, we must remember that a channel bandwidth of 1 Hz can support 2 signaling changes per second through it. So let us just note that 1 Hz of channel bandwidth can allow 2 signaling changes or 2 independent pieces of information per second through it. Now note that here the sampling rate is Fs. If Fs is the sampling rate, so Fs samples per second we are transmitting, and each sample is represented by R bits. So R bits per sample. So this implies that the bit rate at which we are transmitting our data is equal to R times Fs bits per second. So that is the bit rate, and assuming 1 bit to represent 1 piece of information or 1 signal, transmit R Fs bits per second, the channel bandwidth required will be half RFS. So therefore minimum channel bandwidth required to support RFS bits per second is equal to half RFS Hertz. Now here R is 5 and Fs, the sampling rate, is given in the problem as 8000 samples per second. So into 8000, and that comes out to be 20,000 Hertz or 20 kilohertz. So the minimum channel bandwidth required to transmit the data, the signal, using uniform quantization, ensuring a minimum of 30 dB SQNR, is 20 kilohertz. Now part 3 of the problem is about doing part 1 and 2 again when a mu law compander is used with mu equal to 255. Now mu law companding is a non-uniform quantization technique, and for that it is given here as a note that when mu is very large, then the SQNR for a mu law compander can be approximated by 3L square upon natural log of 1 plus mu whole square. And for this, we still want to ensure a minimum SQNR of 30 dB and want to compute the number of quantization levels, the number of bits per sample, and the system bandwidth required. Let us now do this part. So non-uniform quantization with mu law. SQNR, when mu is much larger than 1, in that case, the SQNR S by N Q is approximated by 3L square upon natural log of 1 plus mu whole square. For mu is equal to 255, this is 3L square upon ln, the natural log of 256 squared. When we express this SQNR in dB, 10 log to the base 10 of 3L square upon ln 256 squared works out to be minus 10.1 plus 20 log to the base 10 of L, and because L is equal to 2 to the power R, where R is the number of bits per sample, it becomes approximately equal to minus 10.1 plus 20 log L, and L is 2 to the power R, so it becomes minus 10.1 plus 20 R log 2 base 10, and log 2 base 10 is approximately 0.3, so it becomes minus 10.1 plus 6R S by N Q R SQNR in dB. For a mu law compander, this is the 6 dB rule for mu equal to 255, which is a typical value used in mu law companding. Now, using this, according to the problem, this SQNR, that is minus 10.1 plus 6R, must be at least 30 dB. So from here, R 6.67, and because R must be an integer, R is equal to ceiling of 6.67, and that is equal to 7 bits per sample must be used in this case. The number of quantization levels accordingly, of course, these are non-uniform quantization levels now. So number of quantization levels L equal to 2 to the power R equal to 2 to the power 7, that is 128, and the minimum channel bandwidth required equal to half RFS, which is equal to half times 7 into Fs is 8000 samples per second. So it works out to be 28,000 hertz or 28 kilohertz. So this is the problem that we have solved. I hope it must be clear to you. That's all. Thank you.